Okay, so let's talk about complex rational expressions. Okay, so what's a complex rational expression means? So that means you have a rational expression. So numerator or denominator containing one or more rational expressions. Okay, so you may have px over qx in the numerator, and you have p star x over q star x in the denominator. So it's a ratio of rational expressions. Okay, rational expressions. So you may have this plus 1, the other one minus x. Okay, minus x. So that's the definition of complex rational expressions. Numerator or denominator has one or more rational expressions. Okay, so it's more complicated. Okay, more complicated. Okay, so now let's look at example. Okay, look at example. So 1 plus 1 over x divided by 1 minus 1 over x. Okay, so this is a rational expression. This is a rational expression. You put them together, it's a complex rational expression. Okay, yeah. So how to solve this kind of complex rational expressions? We use LCD again. Okay, we use LCD again. So we look at all the denominators in the look at these big fractions. Okay, we look at denominators here on top, and we look at denominators in the bottom. Okay, denominator. And we look at all of these denominators, and then we look at the LCD of these denominators. Okay, so this example is easy because denominator we only have x on top and x on the bottom. So LCD is x. Okay, LCD is x. Okay, so our main job is we want to kill the denominators on top and denominators on the bottom. Okay, for the big fraction part. Okay, for the big fraction. So multiply x on top and bottom. Okay, multiply LCD on top and bottom. Okay, then what do we have? X times 1, so that's x. X times 1 over x. Okay, x times 1 over x. X canceled, that's 1. Right, that's 1. And on the bottom, x times 1, x. X times 1 over x, so it's minus 1. Okay, it's minus 1. So the answer is x plus 1 over x minus 1. Okay, yeah. So simplify complex rational expressions means we don't have denominators in the on top and on the bottom. Okay, and on the bottom. So now let's look at another example. So let's say we have 1 over x minus 3 over 2 divided by 1 over x plus 3 over 4. Okay, plus 3 over 4. So first we look at denominators here. So we got x and 2, right? Look at denominators in the bottom. We got x and 4. So common denominator, least common denominator of all these 4 parts. So LCD is 4x. Okay, it's 4x. Okay, yeah. So we find LCD. LCD is the product of linear factors. So it's x and x, right? So we only use x. And 2 and 4, LCD is 4. Okay, LCD is 4. Okay, so now top and bottom multiplied by this 4x. Okay, so we use LCD to kill the denominators on top. So now distribution. 4x times 1 over x. X canceled, so 4. Right, 4x times 1 over x. X canceled, 4 times 1 is 4. And 4x times 3 over 2, so 2 canceled. So we got 2x times 3, so 6x, so minus 6x. Okay, 4x times 1 over x again, so it's 4. And 4x times 3 over 4, so 4x times 3 over 4, 4 cancel, this is 3x. Okay, so this is the either case. Okay, this is the either case. So now let's look at an important calculation for the Math 30 and even Math 31. Okay, it's closely related to the x plus h, which is closely related to the derivative. Okay, derivative. But for us, it's just a complex rational expression. We want to simplify that. Okay, we want to simplify that. So it's 1 over x plus h minus 1 over x divided by h. Okay, divided by h. Okay, yeah. So there are no denominators for this bottom part. Okay, no denominators for the bottom part. So no denominators here. So numerators, we have x plus h and x. So what's LCD? LCD of all denominators on top and bottom. So it's x plus h times x. Okay? Yeah. So top and bottom, we should multiply it by this x times x plus h. So here is x times x plus h. Okay? Yeah. So the bottom, we should keep it, right? Nothing can be cancelled. So it's x plus h, and h. On top, distribution, right? Distribution. So x times x plus h times 1 over x plus h. So this canceled. 1 times x is x. And the second one, so x times x plus h times 1 over x. So x canceled. We got x plus h. So it's x minus x plus h. Okay? Yeah. So this is negative h divided by x plus h, and h. So now we can see there is a h in top and bottom. So the answer is negative 1 x times x plus h. Okay, x plus h. So in this example, there are only denominators on top, okay, of the big ratio, of the purple ratio. Okay, yeah. So in this case, we don't need to look at the bottom for LCD, okay, because there's no denominator there. Okay, denominator there. Okay, so now let's look at another example. Okay, another example. Okay, so let's have 3x minus 2 minus 2 over x. Okay, 2 over x divided by, so let's change the color. The bigger fraction we use the purple color, right? Divided by another fraction on the bottom. So this is 1 over x times x squared minus 2x. Okay, x squared minus 2x. Okay, so this is harder case. Okay, this is harder case. So now the denominators on top are clear, right? We have x minus 2 and we have x. Okay, we have x. So these are the denominators. On the bottom, so there is a denominator, but it's not factored. Okay, so we have to factor this denominator on the bottom. Okay, on the bottom of this big complex rational expression. Okay, yeah. So factor out x, so the x minus 2. So what's the linear denominator? What the linear factors of the denominator on the bottom? So it's the same, x minus 2 and x. Okay, and x. So on top and bottom, we have the same group of linear denominators. So what's LCD? LCD is x times x minus 2. Okay, so don't use this one, the degree 2 part, as a denominator and then to find LCD. We have to factor everything and then find LCD. Okay, and then find LCD. Okay, so now top and bottom multiplied by LCD. X minus 2, so this is x x minus 2. Okay? Yeah. So on the bottom is easy, right? They just canceled. So this and that canceled. We got 1 on the bottom. On top, so first one, x minus 2 times 3 over x minus 2. So x minus 2 canceled. We got 3x. Okay, and the second one, x times x minus 2 times 2 over x. So x canceled. So minus 2 times x minus 2. Okay, x minus 2. Okay, yeah. So this is 3x minus 2x plus 4. So this is x plus 4. Okay, x plus 4. Okay, so this is the other case. If there are degree 2 expressions in the complex rational expression, you have to factor it. Okay, you have to factor it and then find LCD, and then top and bottom multiplied by LCD. So LCD is very important. Okay, LCD is very important. We use LCD to add, to subtract. Now we use LCD to simplify the rational expression. And next time we will use LCD to solve equations. Okay, to solve equations. So one more example. Okay, one more example. Okay, so let's look at this. 1 over x plus 1 divided by 1 over x squared minus 2x minus 3 plus 1 over x minus 3. Okay, minus 3. So now we have 3 denominators, right? 3 denominators, 1 on top, and this is degree 2 on the bottom, this is degree 1 on the bottom. Okay, so denominators, on top, x plus 1. And then on bottom, x minus 3, and then x squared minus 2x minus 3. Okay, minus 3. Okay, so now we cannot just multiply them to find the LCD. Okay, to find the LCD, we need to factor this degree 2 one. Okay, the degree 2. Okay, so we have to factor this one because it's degree 2. Okay, it's degree 2. So we need ST, right? ST. So S times T is -3. S plus T is -2. So what's S and T? So S is -3. T is 1. Okay, product is -3. Sum is -2. Okay, -2. So this denominator is x plus 1, x minus 3. Okay, x minus 3. Okay, so now what are the linear factors? X plus 1, x minus 3. Okay, so this degree 2 part didn't give us new linear factors for LCD. Okay, so LCD are the product of different linear factors in the denominators, in all the denominators. So it's x plus 1 times x minus 3. So this is the most important step. Okay, you find LCD and then top and bottom multiplied by LCD. Okay, multiplied by LCD. So now top multiplied by x plus 1, x minus 3. And bottom, x plus 1, x minus 3 for the first fraction, and then x plus 1, x minus 3 for the second fraction. Okay, second fraction. Okay, so now let's cancel, right? This and that canceled, so we got x minus 3 on top. And on the bottom, so this is canceled, right? This is canceled. The product is x squared minus 2x minus 3. So it's 1 here plus that canceled, x plus 1. Okay, so it's x minus 3 over x plus 2. Okay, over x plus 2. So after you find LCD, this kind of question is very easy. Okay, this kind of question is very easy. Okay, so that's our today's lecture. Okay, that's our today's lecture. Okay, yeah. So let's add another one. So sometimes maybe you have a very bad LCD, right? So let's look at it. We have here 1 over x plus 1 over x plus 1, and then 1 over x plus 2 minus 1 over x plus 3. Okay? So now, for this case, you have to multiply all of them, right? Here you got denominators, x and x plus 1, two linear denominators. Here you got x plus 2, x plus 3. So what's the LCD? LCD is x times x plus 1 times x plus 2 times x plus 3. Okay, and then top and bottom, every fraction has to multiply by the LCD to cancel denominators. Okay, yeah. And then you have a new numerator and new denominators, a very hard calculation because then there will be degree 3 polynomial. Okay, degree 3 polynomial. Okay, so this is the most important step. What's LCD? Product of all different linear factors in the denominators.